When you're writing the orbital diagram or spectroscopic notation, the hardest elements to do are the ones that are farthest to the bottom of the periodic table and closer to the noble gases. So, for example, if you can do, let's say, the element lead, then you can be pretty certain that you understand all of the concepts that you need to for orbital diagrams. So first thing to do is find lead on the periodic table, and then we go up a row and all the way to the end to find the noble gas core, and the noble gas core is xenon. Now, once we find the noble gas core, we just continue with the atomic numbers on the periodic table and we go in order. So from number 54, we go to number 55, which is cesium. Cesium is in the S block, and it is number 1, 2, 3, 4, 5, 6s. We know that this is going to be full because lead is all the way over here in the P block, and it's a number 2p, 3p, 4p, 5p, 6p. So everything that comes before has to be full. So if we write this spectroscopic notation, we know that that 6s is full, and s subshells have one orbital that holds a maximum of 2 electrons. Now, after the 6s, from number 56, we go to 57, but then notice 58 comes down here. And this periodic table is a little bit different than the one that you have on the exams. If you look at your periodic table, between 56, right next to it, where the 57 is here, your periodic table has a little star, and it reminds you to come down here. So there's reasons why some periodic tables put number 57 here and other ones put 57 here. But no matter which periodic table you're looking at, after 6s, we do not go directly into the D block. Instead, we're going to come down here, which is the F block. And this is the first time that we've gone through the F block. And remember, F's start at number 4. So this is the 4F subshell. F subshells contain 7 orbitals. Each orbital can hold 2 electrons, so 7 times 2 is a maximum of 14 electrons. Remember, if you forget how many electrons will fill up the subshell, all you have to do is count the columns. And if you count, there are 14 columns in that F block of the table. From number 71, we go to 72, 73, and now we're in the D block. And remember, D's start at number 3. So the first row would be 3D, 4D, and then finally we're down here into 5D. And we know the 5D will be full, so 5 orbitals in the D subshells times 2 electrons each gives us 10 electrons filling up that 5D subshell. Now we're finally back into the subshell where we find lead, which was the 6p. We're not completely going to make this full because we only need to go over 2 columns to get to lead. So the last 2 electrons go into that 6p subshell. And you can see that they show you on this table 6s2, 6p2. So again, they're only showing the valence electrons on this table. But this is a way for you to check to see if you have the correct spectroscopic notation. When it comes to the D and the F, you will be given elements where you end up in the D block, but you won't be given any where you end up in the F block. Now we had to go through the F in order to get back to the 6p. So you'll have to go through here and then maybe back into the D and back into the P like we just did. But you won't be given any of these elements. And the reason for that is they don't follow the rules as closely. There are some exceptions on the periodic table, but for this class, you don't need to worry about what those exceptions are.